This presentation focuses on the concepts covered in Module 7. We will discuss agent-agent interactions, artificial life, how programming can be used for modeling, simulations, and finally the scientific method. First, let's talk about agent-agent interactions. NetLogo agents can interact with other agents. In order to interact, we need to check if there are other turtles on the same patch with the turtle we are considering. The two commands listed here can be used. The first checks for turtle presence on our patch, while the second is more specific and checks for turtles satisfying certain conditions. The conditions can be color, size, and basically anything describing a turtle. Next, we'll discuss artificial life. There are many ways to define life and its meaning, so people do not always agree on what is and what isn't artificial life. Another reason is that it may vary in complexity. It can range from mere existing to movement, reproduction, death, and interaction with others. Two interesting concepts are the weak claim and the strong claim of artificial life. The weak claim is that computational systems are models of actual living systems. There is a focus on understanding and an attempt to use them to predict things. The strong claim, however, is that computational systems are in fact alive, with a focus on building and trying to get things to work. There are questions that can be asked about programming and modeling. What is modeling really? And how is programming a type of modeling? We also need to consider the elements of a model. There must be a version of reality, something our system is a model of. We usually have objects and rules for their behavior, as well as a mapping between them. There is a kind of relationship between their reality, the objects, and their rules. Furthermore, there is the possibility to use these for making predictions. You probably know by now that computers can be used for simulations. Computer simulations are gaining popularity in several areas, including government and industry. They are useful because they can help with design, creation, and evaluation of complex systems, especially when changes to the actual system may be difficult to implement, expensive, or otherwise impractical. There are many examples for computer simulations. Some of them are weather forecasting, flight simulators for training pilots, and car crash modeling. There are also many ways to classify simulation models. One is into discrete, continuous, and mixed models. In discrete models, changes occur at specific times. In continuous models, changes occur continuously. And as you probably guessed, mixed models contain both discrete and continuous elements. Finally, here are some facts about the scientific method. It is a way of asking questions and trying to answer them. To do this, it must follow a series of steps. First, we make an observation about something. Then we ask a question about what we observed. Next, we try to create a testable explanation, also called a hypothesis. We make a prediction based on the hypothesis. This is followed by an experiment to test that prediction. Once that is done, we refine and iterate. It is possible that the explanation is not supported by the experiment, or that it only explains part of it. We'll have to keep asking questions and testing. Thank you for watching the video.